So the next topic that we're going to discuss is logarithmic differentiation. The idea here is just to develop more differentiation techniques. So this is just going to be adding more to what we already know. So when you want to use logarithmic differentiation is whenever you have a function and then also a function as your exponent. So it's a function to a function. Kind of the idea here is that you should have an x in the base, but you should also have an x up in your exponent. So this is not, so here's some non-examples. This is not something like 2 to the x. So 2 to the x only has an x in the exponent, so that's not what we're talking about here. We're also not talking about something like x to the fourth. So here x is only in the base. What we would use this on is something like sine of x raised to the x squared. So here I have my variable in the base with sine of x, but I also have my variable in the exponent with x squared. So how we're going to do this is, let's say that you have a function to a function. You're going to start with use the fact that anything, so I'm going to use a little heart here, can be rewritten as e to the natural log of that anything. Once we rewrite the problem, then we're going to use the chain rule and also the product rule. So we're kind of turning the problem into something that we know how to do. That's the whole point, is that we know how to use the chain rule, we know how to use the product rule. So rewrite the problem to be something that's easier and then go from there. So let's do a couple of examples here. On this first one, so I have 2x to the 2x. So we're going to rewrite the problem. So I have that 2x to the 2x is the same as e to the natural log of 2x to the 2x. So I've rewritten the problem, and the reason we use the natural log is because the natural log gets rid of exponents. So we have, and I should say, it wasn't very explicit, but this 2x, the whole thing should be being raised to the 2x. So I'm going to bring out my exponent. So e to the 2x times natural log of 2x. So my exponent came out front, and now we're ready to take a derivative. So to take this derivative, we're using the chain rule. My first function is everything that's in that exponent. So 2x times natural log of 2x. My second function is e to the x. So my exponent was function 1, the exponential was function 2. So then my derivative is going to be e to everything. So that takes care of that second one. But now I got to multiply this by the derivative of my number 1. But to do that, that's product rule. So u prime is 2. So u prime v plus, and then now u v prime. So my u is 2x, and the derivative of natural log of 2x. So that's 1 over 2x times 2 because of the chain rule. Now let's just clean this up just a little bit. So I have e to the 2x natural log of x. Can't really do anything with that 2 natural log of 2x. But in the second part, my x's cancel, these 2's cancel, so all I'm left with is 2. So I think that's our derivative. Now I'm going to move over to the second example. So I have cosine of x all raised to the x squared. Since I have an x in the base and also in the exponent, we're going to know that we're going to use logarithmic differentiation. So to start with, rewrite the problem. So I have that cosine of x to the x squared is the same as e to the natural log of cosine x to the x squared. Just like before, the reason we do that is because the exponent, that exponent of x squared, can now come out front, and I've rewritten the problem. To take the derivative, I have an inside function, which is everything that was in that exponent. So it's kind of a big first function. That's okay. And then my second one is e to the x. And now we can take the derivative. So the derivative of e to the x is just e to the x. I'm not going to put an x. I'll put everything that was above it. So x squared natural log of cosine of x. And now to take the derivative of the first function, so my inside function, that's another product rule. So u prime v plus u. Now the derivative of natural log of cosine, so that's 1 over cosine times negative sine. And so there's our derivative. Two more examples here for us to work out. So I have this x to the minus 3, x minus 3 to the cosine of x. So just like we've been doing, because x is in the base and the exponent, we're going to start by rewriting it. So to rewrite it, we'll say this is e to the natural log of x minus 3 to the cosine of x. Once we do that, that cosine x is going to come out front. So I'm just left with e to the cosine x times natural log of x minus 3. And now comes a time where we take the derivative. So you can write out the functions if you want. I'm going to not do that this time because we've done two examples already. But my inside function would be everything in this exponent. My second function is e to the x. So the derivative of e to the x is e to the x. So e to the cosine of x natural log of x minus 3 times the derivative of my first function. So derivative of cosine negative sine. So there's my u prime v plus u v prime. And that gives me the derivative that I was looking for. Now one more example over here. Last example. It might be a good idea for you to pause right now and try this one on your own, but if not, it's okay. I'm going to rewrite the problem, and let's see if I can do this all in one go. So I'm going to rewrite my problem to be e to the 2x natural log of 2x minus 4. Now I know I skipped some steps, but you can go back and look through them if you want. I rewrote the problem to be e natural log of my entire function, and the 2x that was my exponent came out front as my coefficient. Now for my derivative. Again, first function was this entire exponent, second function was this e. E to anything is still e to anything. So natural log of 2x minus 4. I'm running out of room, so I'm going to write it on the next line. Times the derivative of the exponent. So u prime is 2. So u prime v plus u is still 2x. Now you got to think the derivative of natural log of 2x minus 4. That's 1 over 2x minus 4. But because of the chain rule, you need to multiply this by 2. And I'm going to simplify this just a little bit. So I still have the e 2x natural log of 2x minus 4. But on the inside, I have 2 natural log of 2x minus 4. And this second term is the one that we can simplify. So I have 2x and then also a 2, so that gives me a 4x in the top of the fraction, and then divided by 2x minus 4. So there's my derivative. Just remember, use this whenever you have x in the base, but also x in the exponent.